that we're about to hit 1 o'clock, so we might get underway. Thanks everyone for joining us in this session. Just so you're aware that we're going to record the session, so if anyone objects to that, you might want to not speak, but yeah, we're going to record the session for viewing later. Welcome, my name's Eric Bajaya. I'm the Chairman of Building Smart Australasia. Before we start, I'd like to acknowledge the traditional custodians of the land upon which we meet, wherever that may be for you, and pay my respects to the elders, both past and present. So welcome, thank you to all of you for joining this first of a 2022 technical webinar series that we're going to run throughout the year. This one is generally sponsored by Trimble. It's something that I guess feedback from our members over the last year that they wanted to see more of these technical webinars. So one thing we've done as a board is decide that we want to run more of those this year. We've decided that the first one that we want to run is probably on an area where IFC probably doesn't get a lot of attention, or openBIM does not get a lot of attention, and that's in the area of linear infrastructure, and particularly the use of using IFC in the field. Now, I guess a lot of us understand that there are challenges. IFC wasn't specifically made for the field, well, the current versions of IFC, but we'll talk about a bit about that later. But what you're going to see today, I guess, are some good case studies of how it can be used in the field, even in its existing form, some of the challenges around that, and I guess some of the solutions on how we're working around that. And also we're going to give a very brief update on what's happening with IFC 4.3, which hopefully solves some of those challenges as well. So as a start, a little bit about Building Smart for those of you who don't know who Building Smart are. In Australia, there's 4 things that Building Smart do. Yes, we are the custodians of IFC and we maintain it and develop it. So that's one part of what we do in Australia, or Building Smart internationally, is the developer of the openBIM format, particularly IFC, but also some other open formats for use in the digital space in the AEC industry. We do a bit of advocating work, so there's no point having an IFC format unless we are transforming the way we work digitally. So we do a bit of that in Australia, where we work with a lot of governments and other departments to look at pushing digital transformation to allow for us to use formats like IFC, particularly in the built environment. Education, and I guess this is part of what we're doing now with these technical webinars, but we're also providing platforms to help educate through certification programs, which will start to roll out an internationally recognised certification program in the next month. That's going to replace our BIMcreds platform, but also doing more of these sort of webinars. And then the other thing that we do is just bring industry together to facilitate a bit of networking and share knowledge in best practices. So they're probably the 4 things that we do mainly in Australia. Very briefly, this is the board as it stands at the moment. So if you have any questions or want to reach out after this webinar or become a member, feel free to reach out to any of us on the board. So didn't want to take a lot of time up with an intro. So I'm going to first of all, before I throw to Wayne, I'll probably just, I guess, give an overview of our speakers today, actually. So we've got 3 case studies that we're going to go through. So, and focusing from delivery all the way through to delivery. So we've got Alex Wong, Senior Digital Delivery Engineer from the Western Program Alliance, Tim Anderson, Project Surveyor at Gretzel Engineering Surveyors, and Chris Power, Digital Engineering Lead for Lee Surveyors. And then we're going to have a panel after that made up of Jim Plume, Devon Middletich, and Peter Stewart. So we thank them for coming along from Transport for New South Wales. Lee Gregory and Tim Lemon from Trimble and 12D. So we're going to have a good, I guess, panel where we've got a bit of representation from a vendor, from a client, from Building Smart themselves. So it should open up some good discussion. So without further ado, I'll hand over to Dwayne just to do a bit of introductory commentary, and then we'll go straight into our first use case. Thanks, Dwayne.
Thanks, Eric. On behalf of Trimble, I'd like to thank the presenters and the attendees for taking the time to join the session today. Trimble makes a range of solutions to transform how the world works, and Trimble sponsors Building Smart to give back to industry by streamlining workflows that promote both interoperability and openBIM, such as Building Smart's ongoing work with IFC 4.3, as you covered earlier. This IFC interoperability will be showcased today during the presentation. Interoperability allows Trimble to focus on developing further innovative technology in future, rather than expending development resources on supporting multiple file types from other vendors. Thanks, Eric. I'll hand back to you and the presenters.
Thanks, Dwayne. So we'll go straight into our first presentation. So our first session is going to be from Alex Wong, the Senior Digital Delivery Engineer from the Western Program Alliance. So over to you, Alex. You're on mute, Alex.
Hey, still the buzzword of the year. Thanks, Eric, for the introduction, and also Dwayne from Trimble for the honor to be able to do a bit of presentation here, and not to mention Building Smart as well. So I hope you can see my screen. So I'm Senior Digital Engineer, Delivery Engineering engineers, and been with Western Program Alliance for the last 3 years or so, delivering digital initiative for the project.
You've gone on mute again, Alex. Sorry.
Again.
Can you hear me now? Yeah. All right. So first of all, I'm going to talk about a bit of Western Program Alliance just to show the magnitude of what we use the IFCs in Western Program Alliance. A bit of life before I joined Western Program Alliance, the IFC for design coordination, construction, and what benefit do we get out of the IFCs after we embark on that journey.
You've gone on mute again, Alex. I know.
That's very interesting. I hope I was going to keep an eye on that mic thing. It seems to be going on mute all the time. So Western Program Alliance consists of three partners, if you like. Ourselves, the designers, and the MTM. So ourselves as the principal contractor, and Arup and McConnell as the design partners, and MTM as the owner operator once we hand it over. For the last 5 years or so, we have been constructing 12 crossings, which is now in fully functional here in Victoria. 7 is still under deliver, and 5 is on the way for the next few years. So this is a bit of a video for your, just a bit of teaser for you. So before we embark on the IFCs, you imagine you have all different file formats like this Lego set you're looking over here. You have beautiful buildings that you plan to build. You call it a smart city or digital twin of what you're trying to build. You can see there's building laying around, there's railways, it's sort of not quite connected. So this is a scenario that we're looking at when we first embark on these IFC journeys. And when I first came on board, what I found was we have files all sorts of different format. You have Tekla, you have MicroStation, AutoCAD, all the point cloud information, pictures. And ideally, we want it to sit in the same common data environment and then consumed by all these different platforms out here. So in terms of digital, you've got 3D, 4D, GIS, 5D planning, and eventually as built. What I found really was you got data input, you got the CD, so-called CD, but when it comes to data output and the right platform to consume the information, you're still looking at all kind of information jumbled together. Everyone have no sort of a common understanding of what to use, and just use it as a C feed, mainly because of the dynamic of the project. And not to mention, you have data sources from external hard drive, thumb drive, and sometimes external cloud storage like Dropbox and things like that. So when we embark on this journey, we started off with just looking at the possibility of having IFCs all into one model. So what we have achieved with the IFC is all because of everything is federated under the same file format. We're able to combine all these different disciplines all together, being civil overhead track, architect, landscape, pipeline, underground utilities. So everyone can see everything in the same view over here. Fast forward that with the digital journey, we also embark on our drone survey, where we're able to incorporate the drone survey information, the photogrammetry point cloud, into the same platform. that is enable us to all the users to have a more richer experience in terms of doing their design collaboration. So this is another example of how we are using the IFC model. Having it into the same platform, you can do all sorts of measurement, pinpoint, measure distance, cut cross section, and so on and so forth. Another good example of the IFC model being used is because you have got all these different models being, I guess, collaborated and coordinated all in one platform. With the platform that we embark on, we are able to have a pool of users within the same platform, talking the same language, seeing the same thing, and they're able to provide a comment, any challenges they're facing, any clashes, and then assign it to any discipline of users and solve it from there on. Apart from just the digital collaboration, this one that you're looking at is we're able to combine the IFC models as well as I call it the reality capture of the site itself. For that, not just talking about from design perspective, you will also enable people such as from the construction team to be able to come in the same environment, look at the same thing, have a digital twin of the site before they embark on the construction of the site. The next, this one form a very important step that we do in our digital engineering investment program aligned, which is we call it the 4D planning. So all these models that you're looking at here, they are a real digital model that produced by the designer, where it then gets consumed by the planner, and then it gets further developed by our 4D planner to, we call it a construction sequence simulation of very critical activity on the site. So this one in particular, it takes a lot of planning to get it right. As you can see, you've got very big tower crane that we are having on site, and it's costing us a lot of money. All these construction modules, they all come in the modular form. It's not all fabricated from site, and all need to collaborate, all need to be coordinated. So you call it right time, and so that we don't have any hiccup when we actually do the actual construction. So just looking at this, for example, it give all the user of a good way of understanding what we're doing when they say users. So not just from a construction perspective, safeties, planning, and it gives our vendor a very good understanding of what we are trying to do over there, so that everything can be coordinated and collaborated thereon. So next one that I want to show you is you can see before you build. So this is a Trimble site vision that we're utilizing in all of our project sites. Sorry, this is one site that I'm showing you over here. So the use case over here is we are using this as a tool for underground utilities. So for engineers such as myself and everyone else, anything that above ground is fairly simple and easy to imagine, but anything that hidden underground, it's something that is really difficult, and it's a very valuable information that we can share amongst our team member to be able to iron out any issues before they actually come and dig on the ground. So this is a very good initiative, and this is the IFC model you're looking at as well. So apart from all these initiative, the initiative that we're doing over here is a so-called drone survey by Trimble Cyrus or Propeller Aero. So we got pilots on all the sites, flying all these sites frequently, and the background you're looking at over here is actually a real data set, and all can be measured. You can cut cross section, you can look through them. So in this case, working with the vendor, we're able to open up the possibility of using the IFC models to be able to display this on the same platform. It's a cloud platform, and it's very easy for people to look through it as well. So this platform, in general, we have more than probably looking at 600-700 users over here using the same information. So the power is a very powerful visualization and also planning tool as well. So those are the use case that I was trying to show you, and then I just want to talk about the live after the IFC model is enabled. So previously I was talking about you have scenario where it's a linear data flow where you start from the left-hand side of the screen to the right-hand side. So there's no common theme, if you like, of people of how they're going to consume the information from. So with the opening up of the IFC's file format, it sort of gelled everyone together as a pointer of making the common data environment much more relevant, where you can see over here not just the couple of initiatives that we're talking about, the 3D, 4D, and 5D or as-built planning, with the IFC models in mind, come in light. We also able to get into things like drone survey, which Tim will talk to you about, sustainability, where they're using the same IFC model to talk about how they're going to use this model to do the calculation for sustainability, and quality team looking at the same information as well, in terms of making sure we build to the level of quality that we are talking about, right spot, right location, and so on and so forth. So now I was going to hand over to Tim to talk about his part.
Okay, can everyone see the? Oops, sorry. Can everyone see the screen? Hello?
Not yet. Not yet.
Not yet. Oops. Where's that? The content. Oops.
Tim, there should just be a little share button in the top right.
We can see it
yeah.
now.
Amazing.
Yep,
Perfect.
we
Did
got
that work
it
now?
Yep, just go to full
Yep.
screen on you.
Yeah, okay. I'll make that big.
Yep. Cool.
Thank you. So yeah, I'm a project surveyor with Gertzel Engineering Surveying. I've been surveying for about the last 15 years, and we've seen a lot of changes in that time. Yeah, so Gertzel itself has been around for 39 years in the civil engineering stream. It has been around since 1983, and one of the real big game changers was a Geometer 4000, which meant that you only needed one person to do survey. And in a way, IFC files are sort of becoming similar to that. It's sort of changing the way in which we conduct our surveying in the field. And so what we're really looking at now is the best practice of how to implement IFC files in field set out. In particular, in this presentation, I'll focus on the Western Program Alliance projects that we have conducted as Gertzel and WPA together. So we've been involved with the Western Program Alliance since the start, and as Alex said, like there has been a massive amount of change in the way in which the data has been handled, and moving towards that common data environment has meant like it's much easier for the surveyors to be confident in their set out of the data because we have more sources to compare to. So yeah, we've started probably 2018. I was on Corrick Creek, Aviation Road, Wyndham Vale Stabling Yard, Cherry Street and Werribee Street are the main projects there that I've been involved in. In this slide, I'll just go through the field hardware and software that we've got on our controllers. So what we take out in the field and how that's sort of changed, particularly with the new controllers and the new field software.
Excuse me, Tim, I'm
Yep.
just wondering, am I the only one who can't see your shared screen?
I can see it.
I think
I
so.
can see it
think
fine.
we can see it. Yep.
We
Yep.
can see it.
You
Okay.
might have to log out and log back in, Harry.
Okay, cool.
Okay. All right, cool. Yeah, so we'll go through the use of IFC files in real world use, like just loading up the IFC files straight into the controller. And then I'll go into how we've used the IFC like 3D model files in conjunction and sometimes replacing the paper plans that have been issued for construction. And then I'll just close off with the advantages for us and some of the disadvantages, or probably more the challenges in which we're faced in using the 3D modeling software or the IFC format. So here's a, on your left of the screen is the TSC3, and that was released in 2011. It doesn't have like a 3D view. The software, like the operating system's a bit older, and it's like quite a lot longer to load. It can't accept an IFC file. On the right is the TSC7, which does have the 3D view, and you can see a picture of basically the same bridge, which is one of the ones at Werribee Street, in just that imported file that took about half a minute, like 30 seconds to import. And you have the whole bridge structure sort of up and ready to go. The TSC7 was released in 2018, so it's reasonably new for surveying as things sort of move slowly with procurement of gear and sort of changing stuff. So what I'm going to go through now is this was a real life situation that occurred at Cherry Street. We're for Western Program Alliance. So we're putting in basically a linear CSR. So we're putting communication, electricity, cables in basically in the early work stages of the project. And one of the problems that was identified, or one of the risks that were identified by the engineers, was we're going to go under a future structure being a set of stairs, which you can see highlighted, circled in the left of the screen there. And that's the information on this screen is normally all the information that I have to make a decision. Are we going to be able to sort of, you know, miss these stairs? Are we actually adding a live service into our work area and adding risk? And so what they came back with was they gave me this. And I remember looking at this for the first time and thinking, how in the world do I use a 3D file that looks like this for set out? So after a couple of phone calls, someone said, oh, you can actually just load it straight up onto a controller. And I said, oh, okay, I don't have that controller. And they said, oh, this other one by another company said, yep, you can just load it straight up and set out straight off that controller. And so that's what we did. And essentially in this situation, which is early works, which I'll just show you the controller. So that's the line there set out. And then we could ensure, because those stairs are at an angle, that at the lowest point on those stairs that we had the correct cover. And that correct cover prevented that service from being in the future work area. So with permits and all of that, we were able to utilize that. Now I had the whole site as IFCs. I walked around with the supervisor, and in a similar situation, we're able to prepare works. So the laydown area, in this case, we could decide, okay, this is where the laydown area will be, and we can get in ahead. And if there's asbestos there or cultural heritage, we're able to now get in long before I'm able to actually get the IFC plans and comp it in. So this has been the biggest problem probably for surveys. I get a PDF and people go, all right, I've given you the PDF, can you now go set it out? And it's not that simple, but if receiving the IFC, it actually is, because you can just upload the IFC straight into the controller, and it's brilliant for information only set out. Maybe not so brilliant for the actual construction set out, but I'll go through that in the next little bit. So there's the completed job. That's what it looks like now. I believe that was a very good result, because we were able to control the site in a way I'd not experienced before, and I was very impressed with the use of IFC data. So I was on that job, and very quickly another surveyor left, and they went, and I was handed this job. This job was 120 days of 24-hour rail occupation, and I had a month to get ready for it. And so looking at this picture, I used to look at these pictures and go, wow, it'd be fantastic to get this data, put it on my controller, and just see how that looks. In this case, thanks to Alex at the time, we were able to do that. So we're able to get the data for the whole site, which then enabled me to do planning much more accurately than it would have been from plans. And we're able to cross-check the data as we're computing the structure of the bridge. We're then able to cross-check the data. in one of the structures, which are the walls approaching, the L walls that were approaching the bridge, we actually used the IFC data and extracted it and manipulated it for set out. So in this picture here, down in the bottom right corner, you can see that purple symbol. That purple symbol is the set out point. Although it's not part of the IFC data, in this case, the IFC data was used to prefabricate the L walls. So that was the most accurate data that we could receive. With this data though, we also needed to check rail alignment to make sure we had clearance. So we used the IFC data in conjunction with our other data, like that we computed on the job, to ensure that we met the compliance for the client. And that was really important for us, was to ensure that compliance. So sort of taking an IFC file, loading it straight up in this case, and then setting it out in the field, we weren't very comfortable with, just because we wanted to do the quality assurance on this. So that's been our experience with yeah, the IFC sort of stuff. So the advantages that we've really identified, and this is across a lot of projects, not just Western Program Alliance. I had a talk to people from various companies and various projects. One of the biggest advantages is we know, like, we don't need to go out and set out a lot of services and all of this for engineers just to have a little look, because that's one of the really frustrating things. Oh, can you just do a visualization set out? So with Propeller, they're able to sort of see exactly in a 3D environment, and with the aerial image and with as-built of services and that, they're able to see what it looks like. And that's been, although it's not directly survey related, it has saved a lot of time. And like sometimes people come to me and I'll say, have you had a look at Propeller? And they'll go, oh, no, not yet. And I said, I'll have a quick look at Propeller and then get back to me. And they said, oh, no, I've got my answer from Propeller. That's a very big win. If we're trying to get together as constructed files and all these other files that we're trying to do, it does allow us to have more time in the day. One of the other really big advantages, which I've noticed as the data comes in, the entire work site's there and it's spatially correct. So it's geo-referenced. It all links into each other. So we're able to analyze the interfaces, which are quite often very hard to analyze otherwise, because we, on a plan that may be made in March, one made in April may have a different interface. But with the 3D model, we're able to say, okay, that's what's going on. And then if we raise a question back to the design team, we're able to take a screenshot of that. So the RFI and the answer for our questions come back much faster than they have previously. And so that's been an absolute advantage in speed of the communication. So that's been really good. It's very fast to upload. I think for some of these screenshots, I just uploaded the IFC file with under 30 seconds. You can do it remotely through like various like Dropboxes and all that, so the file can be uploaded remotely. There's no need for comps for this. Like if we're just setting out for information only in that, we're not really having to do any survey comps, which can take quite a long time. For example, the bridges at Werribee Street took 2 to 3 days to do the comps, and they're very, very similar to the IFC file. So we could have actually nearly set out using a verified IFC file, which would have saved us like 3 days of work. Some of the big disadvantages that we've found is people aren't really experienced with IFC files. Like looking at a 3D file can be quite intimidating at first. So with the inexperienced user, which is us, like we're not designers, we're not modelers, so we're now looking at a new file format. We're used to points and lines and surfaces. So we're wanting to set out our points, lines and surfaces because that's what our equipment allows. And so how to sort of manipulate this file to set out the points and lines and surfaces has been a good learning experience, because it's actually quite simple with a lot of the software. So the software providers on the controllers for survey in the field have been brilliant in allowing us to do this. It's very large data sets to what we're used to. So our data management sort of has to change. The data sets are, you know, whole site data sets, where before we may have just had a DXF of, say, the bridge, a DXS of drainage and that. So that whole data sort of coming together, it can make it confusing for us a little bit. One of the big problems that we've had is the data, because we have it, can be used as set out data. and this would scare designers and it scares survey. If someone gets the data and misuses it and sets out with it, then that's sort of one of the other troubles that we face. So we must sort of be pretty stringent on our control of IFC files and how that data is set out. Quite often, if I've got a young surveyor, I'll just provide them the exact points they need to set out, or the exact line they need to set out, or the exact surface, and that stops like a lot of the data that could be potentially set out wrong. And data managers and surveyors in this case really need to be updating these files regularly, because if you're using this file as a set out file, and if you're using it for information only, the nature of the design as it changes, it needs to be updated. And so with the remote at the moment, like we've been able to update remotely to the controller, that's really good. But if someone's using a bit of like not updating that and using the older one, data managers need to ensure those systems are in place to update. There's a couple of subjects I haven't approached in this video because we're still in the early stages of working them through. One is the as constructed data. We're coming into IFC file format. It's something that we're looking at, and as Alex has addressed, is the common data environment. We've invested heavily in ensuring that we can engage in the common data environment. So we're using 12D as one of our platforms, and also using Trimble Business Center. And so we're with the IFC file, what's been brilliant about that is it comes across the same in all of these formats. So if I'm using MicroStation, or if I'm using 12D, if I'm using Trimble Business Center, spatially, and aesthetically, it comes across looking very similar, which is really important for us in the way in which we handle the data. The other part that I haven't probably addressed here is also the attribution of the data. So we're actually at the moment going out and recording services with attributions to allow the designers to sort of create themselves a really nice IFC BIM file for services. And we're managing that both in 12D and Trimble Business Center and MicroStation, and because it's an interchange format, it's been really easy to sort of switch between all those platforms. So yeah, thank you.
Thanks, Tim. Oh, that was really good. We'll save questions till the end and for the panel, and hand over to Chris. Thanks, Chris.
Thanks, mate. Can you see that okay, everyone? And can you hear me?
Yep, it's come up now.
Yep. Okay. Yeah. So I think we haven't got a hell of a lot of time left after that. I got eclipsed, I think. But I'll just sort of jump through this. That image you're looking at is just some MLS data. So that's just sort of more or less shows where survey's getting to these days. We kind of picked that up in 10 seconds, basically. It's just a drive-by survey method, but if you control it correctly, you can get down under the 20 millimeters. So we jump back 4 years to where we first sort of started working with point clouds and IFC for bridges. So this is a bridge example where basically the first problem we came across was that the bridge was actually to be built in stages, but the model wasn't in stages. So we realized that if we were to store data, attributes and whatnot against these objects, then we would probably need to learn how to create them ourselves. So what we did was clean up the point clouds and very quickly taught ourselves how to create 3D face sets in DXFs and put those directly into Navisworks. So once we were able to do that, then we could basically track the construction of the bridge. So we had obviously stage 1 was there so that we could get the bridge open and get the bridge off the traffic next to it, so we could demolish that and then follow up with stages 2 and 3, and basically just apply the same methods to the whole rest of the data. So that was I think the first LOD 500, which was basically we didn't use a hell of a lot of IFC at that stage because we were a survey and it was 4 years ago, so it wasn't really used broadly in the survey world. So what we did do though was we used these 3D face sets, which allowed us to embed sampled point cloud data into the surfaces. So there's a direct relationship between the objects that are built and the measurement of them. So they are in the place they're supposed to be. So there's just a couple of views of the one that we were looking at. You can see that sort of stippled area in the, that's kind of because there's, it's actually taken using the resampled point cloud as the vertices in the mesh on the face. So using it now also for like sort of constructability assessments. In this case, there's just the placement of some piling rigs. And, particularly in areas where you're kind of looking at things, a lot of action going on in a very small space. Like for example, here you've got some bridge works for a road widening that it basically has a fairly substantial culvert coming underneath that, and over the top of that there's like a shared cycleway and pedestrian way that sort of threads underneath the off-ramp. So there's a lot going on in one space, so it's not a bad tool. All the like site engineers have gotten pretty proficient with Navisworks, so they can start sort of getting all this stuff. And obviously having the MLS and the UAV point clouds for context is really useful as well. Actually, the MLS, the note on that is that it's kind of accurate enough to do survey measurement from. That's another view of the same job, but just a little bit further up where there's some road widening and the, well, I haven't got enough time, so I won't go all the way through it. This one actually didn't have a model produced for it. It was like the design for it was done pre the times where everybody needs to do it in IFC now. But the survey department did produce one anyway, because like we're looking from abutment A to abutment B there, and this span 2, 3, and 4 are all to be placed by cantilever. So the company that was engaged to do that actually asked us for the model, so we just whipped that one up out of the design itself. This one is actually another end of the same job. So what you're looking at there is UAV data, basically for anything that's off the road, and MLS data on the road, and so it's RTK pickup. So I think with the road we're getting under 20 millimeters accuracy, and with the UAV with the RTK pickup I think we're getting under 70. So it's sort of usable stuff, and surveyors are getting used to using mesh, solids, and point clouds now, so not a big deal for us. Another view of the same thing. Obviously, this is a design that came. It was put out for tender a few years ago. So I just want to sort of, part of the thing that's been required of surveyors now is to keep a progressive as-built. So what we're sort of doing is, taking the existing survey and then just using survey to plan against that. I mean, using design to plan against that, but also then interfacing with the as-built. So, for this widening of this section here, you kind of, you can pull out enough data to get the lifts, and those can go straight into machines, and the cuts, and then the gravel placements, and the CTB, verge barriers, concrete barriers, and, all the way through to asphalt and road furniture, and then, undertake the switch and carry on through there. So, another thing we did trial at one stage, which I want to talk to Dwayne Rosie about a little bit further, maybe later, is some of the Earthworks stuff. So what we did initially was we just followed the traditional pattern of doing surface-to-surface Earthworks volumes month to month. So that's like falling off a log, more or less. You can, because you've got the surfaces there, you can easily create those as, discrete watertight mesh objects. But really, all you're really doing, you can store information against them, obviously, but all you're really doing there is showing where the dirt used to be and where it came from. Whereas we probably want to know like more about where it goes and what subsequent uses as well. So there was some discussion about potentially using block models for that sort of thing. Obviously, you sort of model it all the way down to the lowest cut and then backfill it with all the pavement objects and everything like that. And I'm back at that slide. Another thing we did was for driven piles, we went and sort of scanned all of those with an SX10, and we were able to sort of compare with the IFC model, but also by fitting, you know, known shapes, in this case hexagons with the top and the bottom of the visible, we could sort of calculate the azimuth and zenith, and then like sort of fit the actual model back to that trajectory, and you know, then kind of you've got more or less, I think, within about 50 millimeters of the true position. So I guess, you know, probably what's obvious is that with the points and mesh and solids, surveyors are becoming familiar with it. So what it really does is sort of open up a whole lot of opportunities, because there's a hell of a lot of data coming through. And I'm not suggesting that there is already a spot running around picking up survey data in Australia, but I can see that there could be a useful one. So like I can see a scenario where if you had one of these instruments that was capable of locating itself within a control network and could actually pick up a scan as well as set out, you know, using your diverging lasers, then you probably got something that could find a use for. But I think the big thing is that not that we can't pick up data, we can pick up plenty of data, but it's the data management side of things that really need to change. And this talk about the, you know, the common data environment, it's, every time I talk about it, it seems to come out as a collaboration space for designers, whereas really the real bang for your buck with this kind of stuff is going to come from like spreading that right throughout the construction phase. So you basically now, you know, creating a very similar database 5 or 6 times throughout the construction, whereas you could probably, you know, if you had your data structures in place, just use the one for the whole thing. It, you know, need to be relational, and but you know, this is the place to design databases. So basically, you've got to get all of this stuff talking together, which is where IFC comes in. Hopefully, that will sort of, you know, come through and be really useful. But it's this project data sort of thing, like, you know, this is just to remind you what I was talking about a moment ago, which is that there's a whole lot of different users throughout the project, not only just designers, that could all benefit from a, you know, an overarching data structure. So, you know, we've obviously got the technology to connect to it, and so that, but there's, you know, more than one player, and you know, it's great for design collaboration, but just remember that there's other people involved that would benefit if it was spread more broadly. One of the roadblocks might be this sort of stuff. So it's taking a long time to get into any kind of standard. At the moment, it's on a project by project basis. So writing another FXL for every single one, because like what's required is specific to the contract, and they're all kind of just slightly different. So that's probably about where we are, and I will stop sharing.
Thanks, Chris. Feedback. But I think there's some really good messages there around data structure, collaboration, getting some input from the people who have to use the data in the field from design. So some really good messages there. And we'll cover some of the questions in the panel. We've got about 15 minutes left. So I might just spend a couple of minutes, maybe Jim, if you're on the line, just a quick update on IFC 4.3, because I guess that's an important thing in terms of helping to improve some of these workflows out to the field. I'll just share my screen just with the timeline, but Jim, just want to give like just a 1 minute update, and then we'll jump straight into the panel. And if the panel members could put their cameras on, that'd be appreciated. Thanks, Jim.
Not sure how you, thanks, Harry. Not sure how you talk about 12 years of work in 1 minute, but I'll give it a go. By the middle of last year, June the 30th, last year, we completed the development through a whole series of projects. We completed the development of the IFC 4.3 schema. Since then, we've that included a very thorough process of evaluating it and validating it. Since then, a few things have been going on simultaneously. Probably the main one is up until now, we've had to take that basic standard. We've had to first of all figure out how to implement it in software, how to do the certification work to give software vendors the opportunity to work with it. But there was also a need to incorporate into what we did as an extension specifically for infrastructure to add some other changes that have been requested from the building side. And so what we actually have now is the IFC 4.3, which is an extension for infrastructure, plus some updates on the building side. And we've now produced that as what's called a production standard. And that's now going to ISO in order to be validated or voted on as a new ISO standard. So it's, in summary, the essential fact is that from now until early next year, it's in ISO hands to have it voted on, and it'll be published as an ISO standard, we expect, early next year. That's really the summary of it, Eric.
Thanks for that, Jim. I'll just stop sharing so we can bring people up. Okay, so we've got the panel members on. So there's a couple of questions that came up, and I think this is one that I've probably got as well, because it's one that comes up all the time. So would it be advantageous to have survey control points modelled into the IFC files for a cross-reference check? And I guess supplementing that question is who takes responsibility for that? Because I know that's one that's come up in our jobs about having, whether it's set out points, survey control lines, and getting those modelled in, and then who models it in and who takes responsibility. And I think I don't know if it was Chris or I don't know who mentioned that, but I guess that's a question to the panel. I don't know who wants to talk about that, but just that responsibility of having that information within those models. How do we manage that, and how do we get around those fears of taking responsibility? Because someone's got to take responsibility anyway, even with traditional workflows.
Well, since there's a big silence there, I'll say something. It's not just a problem for this part, it's all that electronic data. There's still, those contracts seem to still want 5,000 drawings, and until they can sort themselves out and say the 3D data is the contract, that's still the problem. And so this is just one small part of that. I know Main Roads Queensland have had a couple of projects where they said the 3D electronic data is the contract and not the drawing. So this is one special case of that. How do you sign off and say this is your? People say it should be hard, but let's face it. Surely you can make a copy of the data you give to the people. It's very easy later when it's electronic to go back and check, is the data identical? So I think it's easier in the 3D data space than it is than with drawings.
Yeah, I'd agree with that. I'm just not sure that control belongs in with the design. I think it's a separate issue.
I tend to think that as an industry, we're not helping ourselves with validating design in general outside of the paper and maybe digital design review space. And so there's an opportunity there where just because it's a model doesn't mean that we don't check it, and it needs the right process in place to validate what's there, whether that's automated or via a human. And so we've got a big gap there as an industry to really get the rig around that and give people the trust in the process.
Thanks, Stephen.
If I can add in there, Eric.
Go for it, Peter.
So the validation of the data is basically we're making a change from what our traditional delivery would be to the 3D model space. So when we go to registered surveyors, there's a responsibility and approval and review process of those surveys. So going into the 3D space and going into those IFCs, there should be an equivalent process in there to validate the data from the providers to the client or to the contractor or whoever it might be. But likewise, there needs to be a data validation on the other side to confirm that that information is readily available and in the right formats and right systems. So I think we still have to look at it as an industry of making sure we've got the right processes in place to have that data validation done.
Yeah, that's a good point, Peter. And that's with anything, right? Whatever's coming across should be validated and checked. And I think there's a few questions there as well around loss of data in transfers, and we just got to ensure that is being checked, and then it can be relied upon. Something has to be relied upon. So at the moment, we rely on a point on a drawing. So I guess it's having that reliance to give people comfort that if they are using that digital information, that it's right. Just going through some of the other questions here, I guess maybe one for you, Peter or Devon. I guess from a client perspective, the importance of the open data format and how you're specifying it and how you're doing some of that validation or checking, or I guess what purposes or uses you're using IFC for in the handover process. So whether it's through the construction phase or then the handover phase. So maybe a bit of a loaded question for you. You're on mute, Devon. I don't know if you're purposely on mute.
That's always one, right? Look, I think IFC is the great converger, and I think if you wind back the clock to how we used to use computers before the internet, we had all these problems about how everything was interoperating. And then the internet came along, and it was the great converger. And then in the design space, IFC is the same thing. Prior to IFC, it was just the Wild West. And so there's this huge opportunity for us to leverage that. And it's obviously, from what we're seeing today in the examples, there's these really good case studies of real world implementation. So there's a potential for it to be the unicorn that can solve all these problems. I think where it falls over, and what we're observing, and maybe a lot of people on this call, is the vendor implementation. And there's such an array of how that implementation is executed that's causing challenges around the interoperability between the data flow when it hops through the different applications into various forms. And so we really need to work better with the vendors, and the vendors have got an opportunity themselves to really align so that the publishing engine within the app is working the same way. And Lee, it's 12D's probably got the best implementation of IFC, and you know that. But there's other vendors who have got a long way to go, and even within their own suite of tools, you're having to have workarounds of going into other software to publish an IFC is just to get the file format, let alone what we actually want from an attribution point of view, is a challenge. But we're still better off than what we were prior to IFC. I think what we've got to get away from is having to go into a dialog box and go, it's this version of IFC going into this thing, and we want this output with this level of attribution. It needs to be like USB. You just plug it in and go. And hopefully, with the coordination that Building Smart is doing with the vendors, and that people like Transport are doing with the vendors, that will help raise that bar to a more consistent level. I don't know, Pete, if you want to add your lens to that as well.
Yeah, thanks, Devon. From what we've seen on the projects and from what our delivery partners are doing, and I think it ties in with the question that was sort of thrown in there about the different versions of the IFC. We know that this is an area that's constantly being developed. We know the software vendors are changing their formats so that we're getting a better result each time. A lot of our contracts were written 1 or 2 years ago, so they had the earlier versions of the IFC stipulated within the contracts. But what we're trying to do is, as long as we can get the data, whether it's in IFC, and some of our contracts say we want the native formats, we know that in a year's or two's time, when the software has improved, when we've got better workflows, when we've got better software applications that can absorb the data, whether it's in IFC or whether it's in the native, then we know we can use that data later. And that's where it sort of goes back to Eric's sort of comment is, why do we want this data? Because we know that this is such an ever-changing landscape. We want to get as much data as we can, because we know in 1 or 2 years' time we can then leverage the metadata that was embedded in those designs or within those point clouds or whatever information it was, and leverage it better as we have used it more so in other areas within our business. And certainly as transport, as an informed client, we know we can use that data better, and we're working with our partners internally within transport to say, look, the data's there, we can now use it for getting this information out and being a much more informed decision on some of our planning as well as on our construction projects ready for handover.
Was actually going to be my next question, so I was going to throw it over to Tim and then probably Lee. So the vendor side, because I guess from a vendor perspective, there are challenges with the way, with the implementation, because I guess you rely a little bit on industry telling you what's required, and I guess that's where some of the breakdown starts to happen. So Tim, I don't know if you want to comment first on that, on some of the challenges as a vendor in trying to implement IFC to meet the industry needs.
The biggest challenge is for us is we work off the control line. So instead of putting the control points in the file, we actually use the long section, like vertical and horizontal alignment, to build. And this has been the biggest trouble, is for our contracts, we have to reference back to these alignments. And so when we're getting IFC, like, we're just getting a big data set, and then we're still adding these control lines in. So we're making 3D control lines and measuring off. And sometimes we receive IFC files and they're exported wrong. And this has been the biggest trouble for us, has been trying to just get really good quality data. And so our engagement, I'm probably really lucky that I'm constantly engaging with the same engineering team and with Alex. And so we've developed workflows and continuously developing these workflows to try and make it a bit more seamless, just because this whole workflow around IFC, it can be expensive to buy new software. And then, like, I've used 4 or 5 different softwares at times to develop one product, just because each has a little bit of a benefit over another. Chris,
I forgot whether we had 2 Tims.
No worries. I actually agree with Tim's comment and some of the elements that he's picked up on there. There's a couple of things. One is, it's a very valid point that some object types are supported in different versions of IFC, as an example. So yeah, Peter and Devin both mentioned different situations where there's older contracts with older versions of format. So yeah, from a software vendor perspective, we need to deal with obviously supporting those different object types as the standards develop. And we need to get involved as early as possible. So that's why we're really encouraged to see the progress with IFC 4.3 and aiming to support it as best we can. But then to the second point of the information that's missing, I think, Devin, you mentioned attribution throughout the workflow. That is one area where we really want to hear more from industry, to understand both as a vendor, what information is most critical to use in the field, and then what information is critical to share back from the field to engineers for as-built or inspection or asset management type of uses. So it's through better understanding of those scenarios then we can expedite adding support to better support those workflows.
Yes, my turn. Yes, as a vendor, the problem with IFC, it is super complex, and there's a million ways of doing things. As much as a lot of these groups have now said, we want BIM files, we want IFC, it really does fall upon them to sit down and say exactly what objects they want, exactly what attributes they want. And that's where it's falling down now, because the vendors, when they just have to interpret whatever, no one will agree. But the authorities asking for this data, they're the ones who should be saying, well, this is exactly how we want this. We don't want a B-spline for something when we don't have that civil. We don't want a NURB surface. We want such and such. And that's where the vendors are having trouble, because without that great recipe, we can go nowhere. The other problem with IFC is due to something years ago called implementers agreement. They don't seem to think if a thing doesn't have a volume that it's worthwhile an object. So they never talk about points, polylines, polygons. And that's critical for surveying and for construction and as built. They can be done in a weird way, but a lot of the BIM packages out there won't even display it. And they're critical to our industry. We've now got tins and we've now got alignments in IFC 4x3. We had them in IFC 4x1 actually, but the other ones need to also be there so that because we need them, as you saw in all those examples. Over.
Thanks. Thanks, Lee. So it's good. I think we've had a bit of perspective from client, construction, out in the field, vendor. So I think we covered a lot in the 1 hour session. Just conscious of time, so we might start to wrap it up there. We will have another series, and I guess we'll decide what the next series is, but we're sort of trying to follow the project life cycle, and we're sort of starting at the back end here and sort of working our way through. But I think this was a really good session. It has been recorded and we will share it for our members. We'll put it up on our website. We're about to launch our new website in the next few weeks, actually. So look out for that. Really like to thank everyone who's contributed to the session. Thanks to Trimble for sponsoring. And we look forward to the next one. So yeah, thanks all and have a good rest of your day. Thank you.
Thanks, everyone. Bye.
Thank you.
Thank you.
Thank you.